Hello everyone. Here on the board I have a right angle triangle, right? And perfectly drawn. And we have an angle which is x degrees. And we label this triangle according to angle x. Here, and this side is the opposite side. This side is the adjacent side to angle x. And this side is always the hypotenuse, which is the longest side, right? Now, we're going to write down the ratio that is associated with the right angle triangle, right? Which is sine of x. So the first one we're going to look at is sine x. What does sine x equal to here? Sine x would equal to the opposite over the hypotenuse. So that's just the opposite over the hypotenuse. What about cos of x? What do you think cos of x would equal to? That would just equal to the adjacent over the hypotenuse. So that's just the adjacent over the hypotenuse. What about tangent of x? What do you think that is associated with? Which ratio? This is just associated with opposite over the adjacent. So that's just the opposite over the adjacent. Right? Well, my question to you this morning is, what if you flip these over? What would you get? So what if you take the ratio opposite over hypotenuse and you flip it over on this side and you write hypotenuse over the opposite? What do you think this ratio would equal to? This ratio would just equal to what we call is cosecant. So that's also cosecant of x. And we're going to do it for the rest. So if you flip this over, you now have hypotenuse over the adjacent. This is just equal to secant of x. And if you flip this one over as well, then you get adjacent over the opposite. Then this is equal to cotangent of x. So by flipping these over, we created three more ratios, which is cosecant of x, secant of x, and cotangent of x. So cosecant of x is equal to the hypotenuse divided by the opposite. And secant of x is just the hypotenuse length divided by the adjacent length. And cotangent of x is just the adjacent length divided by the opposite length. And now we have 6 ratios, right? 3 on this side, 3 on that side. But let's say you want to play around with these ratios. And one day you thought, and you said to yourself, what if you divide sine x by cos x? What is sine x in this case? Sine x is just the opposite over the hypotenuse. So here we have the opposite over the hypotenuse divided by cos of x. But what is cos of x? Cos of x is just adjacent over hypotenuse. So this is just adjacent over the hypotenuse, right? And then you know how to divide fraction, right? Keep the first one, which is just opposite over the hypotenuse. Change the division sign to multiplication and invert the last fraction, so this becomes hypotenuse over the adjacent. But from this, clearly, you can see that hypotenuse can cancel out hypotenuse. So hypotenuse here will cancel out hypotenuse. Right? So what are you left back with? All you are left back with is just opposite over adjacent. Interesting, right? So if we take sin x and divide it by cos x, we end up with a ratio that says opposite over adjacent. But the ratio opposite over adjacent, what is that ratio associated with? Opposite over adjacent, that's just tan x here. See it here? So opposite over adjacent, that's just tan x. So this, in other words, is basically tan x when we divide them. So we can study the relationship to make an assumption, right? What can we say about tan x? We can, if when we divide sin x by cos x, we get opposite over adjacent. Opposite over adjacent. And we know that the opposite over adjacent is basically tan x. And therefore, we can say that tan x then is equal to sin x divided by cos x. Is that interesting? So tan x is equal to sin x divided by cos x. And that here, this that I have in blue here, is what we call a trigonometry identity. Right? What if you change these around and you don't have cos of x divided by sine of x, right? What is cos of x? Cos of x is just the adjacent over the hypotenuse, right? So this is just the adjacent length over the hypotenuse divided by the opposite length over the hypotenuse, right? We're going to work out this. So this is, you keep the first fraction, which is just the adjacent over the hypotenuse, multiplied by the hypotenuse over the opposite. Right? Now here, clearly, if you look, you can see that the hypotenuse will cancel out. This will cancel out the hypotenuse. And all you're left back with is just the adjacent over the opposite length. We can simply say then that cotangent of x, right, means cot. So we can just write it short as just cot, right? Cot x. So we can say cot x is therefore equal to cos x divided by sine of x. Interesting, right? And that's another identity there. So if we have cos x divided by sine of x, we get cot of x. And look at these two. Cot x equal cos x divided by sine x. And look at this one. Tan x equals sine x divided by cos x. One is just the flip of one, right? If you flip this one over, you get that one. You flip that one over, you get this one. Interesting, right? This is beautiful. Let's play around with this some more. Let's say that you're now bored and you want to use a number. And you say, okay, let's say you have 1. And you want to divide these 3 ratios here, which is sin x, cos x, tan x, by 1. You're going to do one at a time. So you're going to divide 1 by sin x first. But what is sin x? This is just 1 divided by opposite length, because that's what the ratio is, right? Opposite length over the hypotenuse. Right? Now we can simplify this, don't it? So this 1 is the same thing as 1 over 1, right? So this is just 1 over 1 multiplied by hypotenuse, because you're going to flip the last one. So this is just hypotenuse over the opposite, right? Now 1 times anything give you back itself, because 1 times hypotenuse, that's just hypotenuse. And 1 times opposite, that's just opposite. So we end up with a ratio that is hypotenuse over opposite. But do we know what this ratio is? Of course. Hypotenuse over opposite is just cosecant of x. Right? So what conclusion can we draw from this? We can therefore say that cosecant of x here, so, and cosecant of x can be written short as CSC. Right? Cosecant of x is equal to, what does you think this is equal to? Just 1 upon sine x. So this is just 1 over sine x. That's it. Wow. Isn't that beautiful? Another way you could look at it, here, sine x by itself here is a sine x over 1, right? So if we flip it over to get a new ratio, we actually did, when we flip it over, we get 1 over sine x, right? Alright. Let's look at another one here. So now we have 1, and we want to divide it by cos of x. And if we want to divide it by cos of x, then this is just now 1 divided by, what's cos of x? That's just the adjacent over the hypotenuse. Right? Can we simplify this? Of course. So this is just 1 over 1 multiply by, change the division to multiply by hypotenuse over the adjacent. And when we simplify this, this just gives us hypotenuse over the adjacent. But what's the hypotenuse over the adjacent? That's just secant of x. Right? That's a secant of x. And secant of x can be written short as SEC. And we call it sec, right? And we call this one cosec. Doesn't matter. But let me write the x properly. But what conclusion can we draw? If hypotenuse, if when we divide 1, when we have 1 divided by cos x, that gives us secant x, then that means we can say secant x is equal to 1 upon cos of x. Interesting, right? And the last one that we're going to look at is when we have 1 and we take that one to divide it by tangent of x, what would we get? Now, this is just 1 divided by tangent of x. But what is tangent of x? Tangent of x is just opposite over the adjacent here. But here we can further reduce this to be 1 over 1 multiplied by the adjacent over the opposite. Because that's how we divide fractions, right? A whole number by a fraction. Give it a denominator of 1, change the division sign to multiplication, and just invert, right? And this, we know that 1 times anything won't change it. So this will just result to the adjacent over the opposite, right? Adjacent over the opposite. But what is adjacent over the opposite? Adjacent over the opposite is just cotangent of x. Right? We get that. That's just cotangent of x. So again, here, what conclusion can we draw? If 1 divided by tan x is just adjacent over opposite, and we know that adjacent over opposite is just cotangent of x, then we can say cot x then is equal to what? 1 divided by tan x, right? And that's it. And all of these are some identities, some trig identities that you need to know. Now these, with the 1 upon sin x, 1 upon cos x, 1 upon tan x, these are called the reciprocal identity. Right? So these are the reciprocal identity. And it's beautiful to know all of these identity, because as we go further into trigonometry, they are going to become useful to us. Okay? Thank you for watching, and do enjoy the rest of your day.